Okay, hello. I think this is our first video. This is actually still the summer. It is the day before school is about to start when I'm making this video, and I've kind of lost track of what I've done. So I think this is our first video. I guess we'll find out if I'm right. You guys can laugh at me in class on our Zoom if I am wrong. So, I'm gonna give you I'm not going to give you a second. I'm going to ask that you pause me to take a second to copy this stuff down. Okay, and then pause me again. Okay, we're not going to be able to get all that on the bottom. Okay, and then there's the rest. Pause me. And then a tiny bit more. Go ahead and pause me. All right, now let's do it. Let's dive into 1.6. So let me just ask you a question. What x value, if I replace x with a number, what could fit into that absolute value? So the absolute value of what equals 7? So everybody gets 7, right? But there's another value. Besides 7, what other value can fit in for that? What can I take the absolute value of to get 7? -7, right? Okay, this is gonna seem repetitive, but I want you to see a pattern here. So what about this x value? What can I plug in for x so that when I take the absolute value of it, I get 2? Hopefully you picked x equals 2 and x equals -2, right? And then over here, I have x equals 3 and x equals -3. So whatever is inside of the absolute value, so this thing and this thing and this thing is going to equal plus or minus whatever is outside of the absolute value, the number, right? Are you seeing that? So the x is equal to positive and -7, x is equal to positive and -2, x is equal to positive and -3. So when we do our examples, that's going to be exactly the same. The thing inside of the absolute value, now it's not just x, but I take the whole thing inside and I set it equal to +7 and also -7. Okay, so that's the first step, and that's really the only step that requires much thought, because from here I'm just going to subtract 1 from both sides, yeah? And subtract 1 from both sides, and then I'm done. So just like up here I get 2 answers, also down here I get 2 answers. So let's do it again. The thing inside the absolute value is equal to positive and negative of the number, right? So +2 and -2. That's the only step that's new from anything we've done. And now I just need to solve. So subtract 4 from both sides. Subtract 4 from both sides. And then divide by 2. Now here's a place where I'm going to tell you guys, I'll say it many times this year, make extra notes on your notes. I'm not going to write every single thing down. So if you're worried, if it's not super intuitive for you to do this -4, write that down, okay? Same thing with the divided by 2. If that didn't come to you without a little bit of help, make sure you write that down as I say it. You can pause me anytime. Okay, so this one, we might be tempted to say x equals 0 and x equals -0 to follow along this pattern, right? The thing inside equals plus or minus, but x equals -0 doesn't really make sense. Zero is neither positive nor negative, so we just say x equals 0, okay? All right, what about this? What can I take the absolute value of that equals -4? So you might be tempted to go just get in robot mode and go up +4, -4, just like up here, right? But is there an absolute value that ever equals a negative? You got to stop yourself, right? This one has no solution. Absolute values are never negative. So here's another spot where I want you to take notes on your notes. If that didn't come intuitively to you, if it didn't like click in your head, then write down absolute values are never negative. Okay? I don't care what's inside of the absolute value. It could be 2x minus 3,742 plus x, just in case you couldn't read that when I gave you time to copy it. 2x minus 3,742 plus x. I don't care what's inside. An absolute value of anything, whatever that thing is, it's got an absolute value around it. It can never equal -1. It can never equal negative anything. Okay? Good. All right, so how is F and G different than all the previous ones? Do you see anything that's different? Pause me and think about it for a second. Okay, so hopefully you were thinking that like in all of these problems up here, I had the absolute value by itself on the left side of the equal sign, every single one of them. And on this one, the absolute value is not by itself. So we need to make that happen. We need to get the absolute value by itself. So we want to get rid of the -10. So how do I get rid of a -10? Hopefully you said add 10. Okay. That's going to cancel out. So now I'm left with just 4 minus z with the absolute value equals 11. Now I can treat it like these previous problems here. The thing inside of the absolute value, I'm sorry, I didn't mention, I'm going to go out of order because G is a little bit easier than F. I'm not sure why I wrote them in that order. The thing inside of the absolute value, once it's by itself, is going to equal positive and negative of the number. And then now I can solve. So I'm going to subtract 4 from both sides. This is a positive 4, so I subtract to get rid of it. I'm going to subtract 4 from both sides. And then I need to get rid of that negative, so I can either multiply by -1 or divide by -1. And same thing here, multiply both sides or divide both sides by -1. Okay? All right, good. Now over here, same thing. I need to get the absolute value by itself first. So just like in normal solving we've talked about before, I'm sure, reverse PEMDAS. So PEMDAS. And remember, these are grouped together and these are grouped together. So I'm actually going to do addition and subtraction first. I'm trying to get the absolute value by itself, so I want to get rid of the +3. So I have 2 times the absolute value. That goes away. And subtracting 3. Now I'm going to get rid of the multiplication and division, reverse PEMDAS. So this is being multiplied right here, so I'm going to divide to get rid of it. And now I look like I did up on these 2 problems up here. I have the absolute value equals just a plain old number. So I'm going to set it up like I did all the previous ones. The thing inside the absolute value is equal to plus or minus the number. And then I just need to solve. So I'm going to subtract 4 from both sides and subtract 4 from both sides. Sounds like somebody's sawing down a tree. I hope that's not distracting. So these are absolute value equations, right? They have equal signs. We also have absolute value inequalities. And when you were copying this down, you were probably like, so Miss Atkins can't spell, but actually I can. So, and versus or. That's the reason I spelled those that way. So this is an and inequality. This is an or inequality, okay? So if you start with a less than sign, you're going to end up breaking it into an and inequality. If you start with a greater than sign, you're going to break it into an or inequality every single time. Every single time. Okay? And it's for both less than or equal to, and then less than and less than or equal to. And then over here it's greater than and greater than or equal to. So let me show you why. What kind of x values can I plug in here for less than 3? I could plug in 2, I could plug in 1, I could plug in, let me grab a bright color. I could plug in 0, right? I could plug in 2.4, I could plug in 1.7. So I can plug in anything smaller than 3. Can you see that okay? I think so. Let me zoom in a little. You can plug in anything smaller than 3. You can also plug in -2, right? Because the absolute value of -2 is 2. Absolute value of -2 is less than 3. That's a true statement. I can also plug in -1. I can plug in everything up to -3. Okay, it's an open circle because there's no equal bar. Well, how does that look as an inequality? I'm not going to write in yellow anymore. You guys are probably freaking out on me for that. This is just x's between -3 and 3. So that's what I'm saying right here. Okay, do you see how this with the a connects to this with the 3? I have a little trick for you on the next page as well. You probably already saw it. Greater than is going to switch into or, so let's look at y. Greater than or equal to now, so I can actually plug in a 2, right? If I plug in a 2 here, this works. Absolute value of 2, that's a true statement, okay? I can plug in a 3, I can plug in a 4, I can plug in a 5, I can plug in anything bigger than 2. I can also plug in a -2 because the absolute value of -2 is 2, and that is also greater than or equal to 2. I can also plug in a -3 and a -4 and a -5 and so on going this way. And if I write those as inequalities, I write this would be x is less than or equal to -2, or, right, out means or. You can't see my hands because I'm too zoomed in. Out means or. X is greater than or equal to 2. Okay, so hopefully you can see the connection between the B stuff here and the 2 stuff there. So let's get this out of the abstract and do an actual example. All right, here's my little way to remember this. Flip the inequality, change the sign. So let's do B first. I again put them in, I don't know why I put them in a weird order, I apologize. So let's do B first. So the thing that's inside, just like before, I'm gonna write it twice, okay? And then I'm gonna write it I actually like to put them in, I actually like to put them in numerical order, so you'll see why I'm doing it this way in a second. So exactly how it is with the greater than or equal to 12, without the absolute value, then flip the inequality, and change the sign. Good? And then I just have to solve. So it's a greater, let me do that in, sorry, I should have pointed this out before. Greater, so that's how I know I need an or, okay? I write it exactly the way it looks without the absolute value. And then I write it with the inequality flipped and the sign changed. So now all I have to do is add 3 to both sides. That's a 9, sorry. That's a wonky looking 9. And then add 3 to both sides. And then I want to write this in interval notation. So hopefully we practiced that enough. This is less than -9, so it's going to go to -infinity. And it's got the equal bar, so it's a bracket. This is greater than or equal to 15. So maybe you need a little cheat. Less than or equal to would be from -infinity to -9. Greater than or equal to is going to start at 15 with a bracket and go to infinity. This is how I want you to write your answers. I don't believe the back of the book shows them that way, but that's how I want you to write them, okay? All right, last one. For just like before, the first thing I need to do is to get the absolute value by itself. So I'm going to subtract 4 from both sides. So I'm going to have the absolute value. That's going to go away. This is a less than. So it's going to be an and inequality. So just like before, I'm going to write the inside 6y minus 2, and I'm going to write it just the way it looks, just like I did over here. Okay? Now when I flip the inequality, I want it to be a compound inequality like this. So I'm going to write it as a greater than. So this one says 6y minus 2 is less than, right? If I'm reading this one, it's saying 6y minus 2 is greater than what's over here. So I am flipping the inequality and then changing the sign. Okay, going over 15 minutes a little. Usually I want these to be less than 15 minutes, but we're almost done, so I don't feel too badly. Solving compound inequality, I need to add 2 to all the spots. There's 3 spots I need to add 2 to solve that equation. So I'm going to have what? Negative 16 and 20. And then again, there's 3 spots that I need to divide. And I'm going to reduce my fractions. These are both reducible by 2. This cancels out. These are both reducible by 2. And then I've got my answer. So this is an in-between. If you need to write this out, you can see it on a number line. 10 over 3, negative 8 over 3. This says y is greater than, so bigger. This says y is less than, so smaller. So in interval notation, I've got that. Parentheses because there's no equal bar. Okay, I got to ask a question now because I want to make sure you got to the end of this. So I'm going to insert a question on Play Pause It right here. All right, I will talk to you guys later.